it will be better if you memorize this one, a plus x whole to the power n. This is actually a short form. In place of x to the power r, we have to put minus x whole to the power r. Minus x whole to the power r means minus 1 into x whole to the power r. We have taken out minus 1 whole to the power r. Good morning. Welcome to B2S Academy. Welcome to my maths class. Today I am going to start new topic, binomial theorem. First let me recall binomial theorem. What is binomial? That means expression involving two terms, a plus b, a minus b, c plus d, p plus q, like this. Sum of two terms. This is called binomial. Now binomial expansion. In lower classes already you have learnt a plus b whole square, expansion of a plus b whole square, a plus b whole cube, etc. Now the question, if the power be more than 3, that means can we determine the expansion of a plus b whole to the power 4, a plus b whole to the power 5, a plus b whole to the power 6, etc. We can find those with the help of the previous expansions like a plus b whole square. To get a plus b whole to the power 4, we can write that a plus b whole square into a plus b whole square. Then we multiply the two expansions. But is there any direct formula or direct expansion? Answer is yes. It was given by Sir Isaac Newton, which is called binomial expansion, binomial theorem. What is that? Let me write that. If n be positive integer, then a plus x whole to the power n, a plus x whole to the power n, that is equal to a to the power n plus nc1 a to the power n minus 1 x to the power 1 plus nc2 a to the power n minus 2 x square plus plus ncr a to the power n minus r into x to the power r plus plus n x to the power n. This expression on the right side of the equality is the expansion of a plus x whole to the power n, where a is positive integer. This can also be written as keeping in mind these coefficients nc1. As we know, nc0 is 1, therefore we can write that nc0 a to the power n minus 0 x to the power 0. As x to the power 0 is 1, therefore we can write this. The next term will be nc1 a to the power n minus 1 x to the power 1 plus nc2 a to the power n minus 2 into x square plus ncr a to the power n minus r into x to the power r plus dot 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 plus nca a to the power n minus n into x to the power n. Now using capital sigma sign, we can write it ncr a to the power n minus r into x to the power r, where r starts from 0 to n. It will be better if you memorize this one, a plus x whole to the power n. This is actually a short form. Now let us clarify the symbols we have used. Notes 1, NC0, NC1, NC2, NCN are binomial coefficients. Next, now the question, how many terms are there? Number of terms in the expansion is equal to n plus 1. Next, note this term. This term is called general term. Actually, this is r plus 1th term. Here I have used that. NCR into a to the power n minus r into x to the power r. This is called general term. Now the question, why we call that general? Because if we put different values of r starting from 0 up to n, then we shall get all the terms of the expansion. That is why it is called general term. This is actually r plus 1th term. Denoted by the symbol T, r plus 1, or some writes small letter. This is the binomial theorem. Now, can we deduce that? Answer is yes. Let us recall those matters already we have learnt in lower classes 7th, 8th standard. We have a plus x whole square. Already we have learned a square plus 2ax plus x square. Now there is no c. We can write that in C0, sorry, 2C0, here n is 2, maximum into a square, or 2 minus 0 into x to the power 0 plus 2c1 e to the power 2 minus 1 into x to the power 1 plus 2c2 e to the power 2 minus 2 into x square. We have learned earlier a square plus 2ax plus x square, a plus x whole square is equal to. Now using c, 2c0, that is 1, that is why keeping this general term in mind, we can write the expansion like this: 2c0 into a to the power 2 minus 0 into x to the power 0 plus 2c1 a to the power 2 minus 1 into x to the power 1 plus 2c2 a to the power 2 minus 2 into x square. Also, we have learned a plus x whole cube, a cube plus 3 a square x plus 3a x square plus x cube. Now using binomial coefficient, it will be 3c0 e to the power 3 minus 0 into x to the power 0 plus 3c1 a to the power 3 minus 1 into a to the power, sorry, x to the power 1 plus 3c2 a to the power 3 minus 2 into x square plus 3c3 a to the power 3 minus 3 x cube. Thus, the theorem, binomial theorem, holds for n equal to 2 and 3. Now, using the relations among NCR and NCR minus 1 or NCR plus 1, we can prove the theorem with the help of method of induction. I shall deduce that later on. Just we, in this stage, memorize this one: a plus x whole to the power n equal to this is this. Now the primary information are these. Now from the binomial theorem, we are going to deduce few results. I have called this relation as A, putting A equal to 1 in A. Left hand side becomes 1 plus x whole to the power n, that is equal to 1 plus nc1 a to the power, a is 1, that is why nc1 x plus nc2 x square plus ncr x to the power r plus x to the power n. Actually, nc0, ncn will have values 1 each. Then replacing x by minus x in A. What we get? A minus x whole to the power A. Originally a plus x whole to the power n. Then if we replace x by minus x, we get this one. That will be a to the power n minus nc1 a to the power n minus 1 x to the power 1 plus nc2 a to the power n minus 2 x square minus, actually signs will be changed alternately. First plus sign, then minus sign, then plus sign, then minus sign, like this. Then the r plus 1th term will be minus 1 whole to the power r ncr a to the power n minus r x to the power r. In place of x to the power r, we have to put minus x whole to the power r. Minus x whole to the power r means minus 1 into x whole to the power r. We have taken out minus 1 whole to the power r plus dot 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 minus 1 whole to the power n into x to the power n. Now again putting a equal to 1 here, putting a equal to 1 in this relation, 1 minus x whole to the power a equal to 1 minus nc1 x to the power 1 plus nc2 x square minus dot 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 plus minus 1 whole to the power r ncr x to the power r minus 1 whole to the power n x to the power n. These are the deductions. Next matter, to find the I call this one as B and this one as C. Next matter is what will be the middle term of the expansion. Middle term, what will be the middle term of this expansion? Like this. Actually that depends on the value of n. To find the middle term. Or middle terms, It depends on the value of n. We don't know whether n is positive even or positive odd. We have to consider two cases. If n be positive odd, number of terms in the expansion is, already I have told, there will be n plus 1 terms. N odd, therefore n plus 1 is even. That means there will be, say, 6 terms or 8 terms or 10 terms like this. Then there will be 2 middle terms. Therefore, there will be 2 middle terms and those are n plus 1, that is even. Therefore, middle terms will be n plus 1th by 2th term and n plus 1 by 2 plus 1th term. Let me clarify. Let there be 10 terms totally. Then the middle terms will be fifth term and 6th term are middle terms. If there be totally 10 terms, then middle terms will be fifth term 10 by 2, fifth plus 1. That is why n plus 1 by 2th term and n plus 1 by 2 plus 1. Now, this is n minus 1 by 2 plus 1 and this is n plus 1 by 2 plus 1th term. Then, considering that a plus x whole to the power n, middle terms will be in CR. Here R is this one, in C n minus 1 by 2 into a to the power n minus this n minus 2n minus n plus 1. That means n plus 1 by 2 into x to the power n minus 1 by 2. Note one thing, sum of the powers will be always n minus r plus r. Total power will be always n. Keep that in mind. Will be this one and in C n plus 1 by 2 e to the power these are will be the middle terms when n is even. Next case, second case I write here. If n is positive even, number of terms is equal to n plus 1, which is odd. If the number of terms be odd, then there will be one middle term, single middle term. Therefore, n plus 1 plus 1 by 2 th term is the middle term. That is n by 2 plus 1th term. Then the middle term using ax, middle term in c n by 2 e to the power n minus n by 2, that will be n by 2 into x to the power n by 2. Therefore, depending on the value of n, when n is odd, then we get two middle terms, and when n is even, we get one middle term.